And we are back. Hey, welcome back, everyone. Uh, Today, we're going to continue to explore more perimeter. So, in the past couple of videos, we have been discussing the understanding of a coordinate grid and how on this coordinate grid we would have some coordinates. And then we started to talk about, well, what is the distance between these coordinates? And then if I looked at the distance between all these coordinates and realized, oh my gosh, I actually see right there that I have this form of a rectangle, or I actually also have through these coordinates, maybe this form of an array, then what is it when I think about the perimeter or the measurement around this entire shape, thinking about how many units occur from one point to the next? 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? And realizing that, oh, the perimeter or the measurement around the outside of the shape would be 14 units. That's how big it is. It's a measurement of how big it is. It's a perimeter. Perimeter goes around the outside. If you were to walk, this is my bird's eye view of the school. I guess, wait, the school is like bigger. It's got like buildings over here and whatnot. And here's the play. Here's the other playground. Look at this. Yeah, it kind of works, right? Here's the field. So if someone said, oh, well, what if you walked the perimeter of the school, which actually some of you during lunchtime have seen teachers doing when we're outside eating, right? You see them actually walking around the perimeter of the school. What that means is really like they're walking around the entire school. They're going around the whole zone. And we could actually eventually measure like how far that is. And that would be the perimeter of our school. We could actually mathematically figure out how far it is to walk completely around the grounds of our school. And that's what perimeter is, right? So that's where we started. Oh, boy, we're like minutes into this and we haven't even really started with the new stuff. I love it when I review so much. And then we took that to the next where we're like, okay, cool. Well, sometimes it's not always just a rectangle, right? Sometimes it could be a triangle. Sometimes it could be a hexagon. But the rules state the same. Again, we're looking at what is the measurement when we move from one coordinate to the next or one corner to the next, and how many units is that? And when it's not a grid, how we can think about, oh, well, maybe someone tells us this is actually 5 centimeters and this is 3 centimeters and this is 7 centimeters, right? So we don't always have the coordinate grid, but we do have measurements and we can just add those together. We can say, oh, the perimeter is 5 plus 3 plus 7. And we'd see the same thing over here, where this time instead of 3 numbers or 4 numbers, I'd actually have 6 because it's a 6-sided shape, but then it's not always just whole numbers. It might be that it's a decimal, right? Each side here is actually the same. It's 5 2/10, which is fine too, because then we would just add up 5 2/10, or right, to find that answer. So 5, 10, 15, 20, 25, 30. And then 2/10, 4/10, 6/10, 8/10, 10/10, or 1. So that would be 31 2/10. I don't know, maybe we call these feet, right? And then that brings us to this other piece where we've been dabbling in these problems. We've actually started to look at them a little bit, which is fine. So this video really won't be showing anything much new than what we've already seen in the screen. And this is what we've seen is we start to get these larger irregular shapes. Right, something like this. And the reality is we are just thinking about how we find the measurement of each line. And sometimes they already have them, right? They're already just labeled. And it's just making sure that we are aware of all the places that we would see a straight line. Because I'll tell you that often there are some numbers that get forgotten or missed. But like here, I don't know, we're gonna make this quick. We're gonna do it in millimeters. Let's just say this is 3 millimeters. And then sometimes like this would be a forgotten line because we might have an arrow pointing to it. Like 5 millimeters. And this is 2 millimeters. and this is 3 millimeters, and this one is 6 millimeters, and this one is 4 millimeters, and this whole one actually would be mathematically 11 millimeters. And we're going to talk about that. Why? Because that's what those would be added together, and those the same distance. And then this would be what? I don't know, 7 millimeters. I made that up, but we have this in front of us, and it's just remembering how to find all the numbers. That's the biggest challenge, because we already can see this and make sense of it. We already know what it is. We are going to add all these numbers together, but I think what often we run into with these problems is just we make simple errors. And so I want to note today's video like on how to like just avoid those. So one thing I like to do that is very helpful is I find a way to make sure I've looked at every number. So like maybe for me, I'm gonna put a little X next to it. So I'm gonna count them when I put an X. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that tells me I have 8 numbers. So what I might do then is say, okay, 1, 2, 3, 4, 5, 6, 7, put this one here, 8. So that gives me 8 spots. And then I know I'm adding all these together. So I'm going to throw an addition sign between each one of these blanks. That helps me organize what I'm doing. Now, the next thing I'm going to do then is write each number down. But when I do it, I'm going to cross it out so I don't get confused. So this time here's 4. So I'm going to put 4 here. And I'll just go in order. We'll do this one here at 6. And then this one here is 3. And this one here is 2. And 5. And 3. And 7. And then 11. Great. So I have all my numbers. And I also need to remember, let's see down here, perimeter. We know it's going to be millimeters. So I'm going to write that ahead of time. And then we're just going to add this together. So I like to just think of like early addition strategies where we group numbers. I'm going to erase that so I have space. But I'm going to do like early addition strategies where I'm going to group chunks of numbers that are easy to work with, right? For example, I see here, right here, that's equivalent to 5, right? 5 plus 3 plus 2, 10. 5 plus 3 plus 2 is 10. So I'm just going to do some quick math here where I'm going to join numbers together to make maybe increments of 10. Look at here, 4 and 6, that's another 10. That's why knowing your friends of 10, first and second grade, remember that? Friends of 10 helps you do this right here, 3 and 7. Well, that also makes it 10. So I've used actually all of these, and I'm already at 10, 20, 30. And I can just add that to the 11 that's left over, and I get 41. And so what also looks like crazy, I have these 8 numbers I need to add together. Well, when we think about how we can combine them in ways with compatible numbers, in this case, I was lucky with 10s, I can put them all together. I'm not to say they're all going to be single digit numbers, right? You may see a problem that has 26 feet, 132 feet, 54 feet. So you're like building these larger numbers. So that way we probably use standard algorithm. But here it just kind of takes something that looks so crazy and makes it a little less daunting. So that would be the answer for that. Now, the other aspect of what we see for these, it comes down to like the missing side. And we've already played with a couple of these problems in class. So they're not going to be really new, but this is just a really good opportunity to make sense of them. So let's do that. Let's say I have something that's like shaped like this, right? And they're going to give me some measurements, but they're also not going to give me some measurements like this. They're going to say, "Ooh, sorry, don't know what this is." And then they might say, but we do know that this is, I guess I'll use the double digits now. This is 13 inches and this is 15 inches. I don't know why this is our voice. We make it so dramatic. Yeah. Sorry. And then this one right here, this line here is going to be, let's make this one 16 inches. And this one is 8 inches. And then this is 29 inches. And then they don't know what that one is, right? So we know for starters, some of the things we can do. One, let's just kind of count how many sides we have. We have 1, 2, 3, 4, 5, 6. So I know I'm going to be adding 1, 2, 3, 4, 5, 6 numbers. We could start to put in what we know. We know 13, we know 15, we know 16, we know 8, we know 29, but we don't know this one. But now we can solve for this one. And how we can solve for this one is really paying attention to this concept again of how, like, if this was on a coordinate grid, where would our distances be? And I'm going to do that right now. I'm going to just pretend. Sorry, I shouldn't even say pretend. The reality is these are on a coordinate grid. We just don't see it. That's why we draw them. Coordinate grids are invisible, but they're always there. But what we can notice is that, like, this point right here, and I'll just make it up just to help me make sense of it. But this point right here, let's just say that's 2 on our x. And let's say that this point right here is 1 on our grid, right? And what we see is up here, this point, this coordinate is the same. It's the same x, right? It's on the same x coordinate. So this is also 2 here. And then up here, well, I don't know. We don't know what this is yet. Because if we did, we would be able to find the distance between these two, right? So let's use some other things we know to help us do that. So I always like to look like, where are some other pieces? Well, if I go back to this point that I'm just saying is at a 1 and I travel out here, I see that this is on the same y, right? And if we know this is 29, well, if this was 2 plus 29, this would have to be 31. So this would be at 31, 1. And then here, oh, well, this would have to be 9, right? Because if this is 31, 1, if I'm 1 with the y, and I know from here to here is 8, right? Because they told me that. Well, then 1y plus 8y would equal 9 ones. So this would be at 9. Right? Which also says that this point and this point are on the same 9, which means right here is actually on 9 as well, which means, oh, this is fun, that this distance, wow, that was, I don't know, let me try that again. Wow, it's like I'm having sidebar writing problems. This distance here, right? This distance right here from here to here is actually 8 inches. And that would make sense because look, here and here and here and here are on opposite ends of each other. So if I know from here to here is 8, well, now I want to think about how could I figure out the distance from here to here? Well, look right across the way. Oh, there's my answer, because actually we know that from this measurement to this measurement is 15, which means this opposite side right here is the same length as right here, which makes this 15. So if from here to here is 8 and here to here is 15, then the entire thing would be 15 plus 8, which is 23. So all that work, and I now realize I have an answer right here. This part is 23 inches. Now, what can get confusing now is I put all these numbers down and where do I make sense of it? And that's why I actually already wrote down all my numbers first, because now the only missing number up here is this 23. So we can go over here and get rid of this, call it 23. Now that's a lot of work, but that starts to make more sense the more we practice this skill. And this also helps us make sense when we understand our coordinates and where points and corners are on a shape, and where they are on that grid and how we can find the distance between them, which is actually the same thing as counting units in an array. Oh, wait, did I just talk about how things are connected again in a video? That's so weird. I seem to do that every time. Okay, so now we have all these numbers added together and they're bigger numbers. So I'm going to do a few things that I do. Here, I know that that's 28, right? 3 plus 5 is 8, 10 plus 10 is 20. So that gets me 28. So I'm going to write that here. Here is 16 plus 8, that's 24. Notice I'm stacking them now. And then I have 29 and 23. I don't know those together. So I'm actually going to write them like this. And I'm just going to do these problems. So let's see, 8 plus 4 is 12. carry over the 10. So 10, 20, 30, 40, 50. So that's 52. But I'm not done. This is also, oh, this is also 52. What are the chances? So now I got to add 52 and 52. That's 4 and 10. So my perimeter of this entire shape, all that craziness, everything I just did there, let's put our answer on the other page, I guess. The perimeter then equals 104, and I need a unit of measurement. So, inches. So we're gonna go back and say inches. So that's really what this work is about. It's like not just can we add up all the sides, but start to recognize how do we find the missing sides, and what do we do with these irregular, we call them kind of irregular shapes, where they're not just a regular poly or a typical polygon, I should say. Regular polygon does have its own definition of just being, a pentagon or a octagon or a square or a triangle, like those ones, boom, boom, boom. But really what happens when we have things that maybe look like that, and we can still find the perimeter because we are still measuring what happens from corner to corner. We're measuring the outside because not everything in the world is shaped like this. So you can't just always measure it that way. Some things are shaped like this. Some things are shaped like this. Some are shaped like this. Some are shaped like that, right? And we can still always find the perimeter of those. So done babbling. I hope today felt good. I feel like with this video, it is really just reviewing some of the bigger problems we've seen with some of our independent work. And I hope that this does make sense. And if it doesn't, that's fine too. Because it's, what I say in every video is keep asking questions until it does. Nothing's going to stick naturally. We don't get it right away, right? We can't learn something for 12 minutes of our life and be like, oh yeah, yep, know it all. No, we just take a little bit and grow from there. So appreciate your time, appreciate your work. And we will see you in the next video.